This is the problem of a sewing machine. A sewing machine could be thought like simple harmonic motion, and it moves from the top to the bottom where it made the stitch is move a certain distance. So the amplitude of the motion is half that distance. So this is the amplitude, half that distance, because a cycle is from the top to the bottom. And 25 stitches in 9 seconds, it means that the frequency is 25 over 9. So what is the maximum speed? Well, the maximum speed, again, is just like number 6, is going to be the amplitude times omega. So you have to remember that omega is 2 pi f, and then it's always given. Let's go to number 9. So you have a spring. It has a certain mass, and this spring oscillates. So it's a spring of mass m, and this is k. And the frequency here that is given is 3 hertz, so it's 3 cycles per second, and it has an amplitude. So what is the spring constant? Well, the spring constant, the relationship for a spring between the frequency and the spring constant is given by this expression. And we have done quite a few times the conversion for these, and so you have to again go to this frequency, and from here you can calculate the mass spring. Now, if the object starts at rest at 12 centimeters, it means the amplitude is 12 centimeters. And the equilibrium point is at 0, so it means that the amplitude is this number. What equation describes the position in centimeters as a function of time in seconds? Well, the equation is, of course, this one, but now you have to input this number here. You probably have to put it 8 times asterisk here to signify 8 times cosine. So, and make sure you do this in centimeters. You just have to type that equation. Now, and again on a spring. Now we go to vertical spring. So to vertical spring, you go to the lecture notes, because I explained this briefly in the last lecture, and it's a little bit tricky. So the spring, when is not when it's vertical, is like that. But when you attach an object, of course the spring stretches and oscillates. But the equilibrium point is not this one, it's right here in the middle. And this distance here, you can calculate it, because right here, the force of the springs times that distance, it has to equal to the weight. So that distance is always mg over k. Now, down here, when the spring, with the extension of the spring is maximum down there, then you have the following. You have a force of the spring that is like that, and then you have mg. And this force is k times twice this distance. You'll get it, and then you'll get an acceleration here, which is a very well-known number. And to calculate the maximum extension of the spring, since you now you just have to write the equation over here, because over here you will have kx minus mg equal ma, and you already found that. So number 11, another spring, vertical again, you have a mass. What is the extension of the spring with the speed is maximum? The extension of the spring with the speed is maximum is at the equilibrium point. And the maximum speed is going to be given by that amplitude times the angular frequency. It's the same always expression for all of them. We continue with the springs. Now we have a spring constant like that. The object is suspended vertically. The spring is initially in its relaxed position. The body is then released and oscillate, and the motion is described by that. What is the maximum kinetic energy of the object? Well, the maximum kinetic energy of the object is going to be 1.5 the mass times the maximum speed. But the maximum kinetic energy is also the maximum potential energy. Remember, the energy conserved. This is the maximum potential energy, and this is already known because you already know the amplitude and you already know K. And to prove this, actually, you can write that this is when I have the mass times the maximum velocity. And we have said that the maximum velocity, what we have said that is the amplitude times omega squared. That's what we have said from previous equation here when we talk about the maximum velocity, right there. So but we also said that the angular frequency is k over m square root. So this is 1.5 m a square. So omega square is k over m. So the m cancels, and this is 1.5 ka square. So this is the maximum kinetic energy, which is also the maximum potential energy. That was a little bit of review on energy. A pendulum, the period of a pendulum depends only on the length of the pendulum. So if I change the mass of the pendulum, nothing is going to happen to the period of the pendulum. So that's trivial. And finally, now I have two situations. In one, I have one period, and then I change the mass. That's not going to do anything. But if you change the length, then the period is going to increase by a square root of 2. So then now you have, so it's going to be square root of 2 times that number, and that is going to do it. Thank you very much, and I need to stop